Good evening to everybody. I hope you can hear me. I want to thank GMA for inviting me for this conference and to attend this. I will talk about portable instruments for screening and ID of laboratory-grown diamonds. These instruments are tested at Canadian Gemological Laboratory in Vancouver, and with many samples over last 10-15 years I did with the Gemmological Research Industry Inc. During many workshops in 17 countries. So this is the outline. In the first part, we'll talk about a little bit of background and standard instruments, and those also based on transparency into short UV light, and other based on fluorescence and phosphorescence reaction to long UV and short UV light. And then I will show you just some results of the instruments. 5 relatively simple: static diamond kit, a jewelry inspector, ARI, J-screen, and Jampen. And in part 2, I'll talk more about more complicated visible photoluminescence and infrared spectroscopy, and these 2 instruments in Spectrum and EXA. Some of you probably use them or heard about them or asked me questions in the past how to use them. So 2 years ago, I started to test these instruments. It was 7 instruments, as you see them on the top. They're in order from least expensive to most expensive. Like EXA is now around 10,100. And then I added another 4 instruments on the bottom. So total of 11 instruments over 1 year, year and a half, I was tested for the conference in Greece. That will happen hopefully next year, but now it's also for the book. Some of these instruments are tested before in the Assure program, but I added more instruments, so it's 11 instruments. Of course, I couldn't test all of them because there are over 50 instruments on the market, and I tested those that I'm familiar, I use in my laboratory, use in the workshops, but also showing you here instruments that I tested during the different venues or shows or conferences, but are not described here. They are in italic letters. There are 3 groups of instruments based on transparency to short UV light, based on characteristic fluorescent phosphorescent reaction, and those based on spectroscopy, some kind of spectroscopy. You can see the list. I won't read now all of them, but we'll go through each of them one by one in the groups. This is the major 3 groups, and there's the first group of combination of long UV, short UV light, and cross polarized filters, the first one called the kit. So most of you are familiar with laboratory grown diamonds or static diamonds, and basically the 3 or 4 groups, those near corollas that are mostly concerned for the trade, usually type 2A, yellow to orange, that are mostly combination of 1B and some of 1A, and those that are pink or red or colored, they're mostly type 1B, could be also 2A, and more blue, they are type 2B, could be HBST grown or CVD grown. Now they could be as big as 20 carats. I tested 10 carat corollas and 20 carats. I've seen 20 carats colored laboratory grown diamonds. And this is kind of a summary I like to present in my workshops. I won't read through all of these, but look at the bottom. What we are using these characteristics for instruments, we are checking the basically type of diamond as natural, mostly type 1A, let's say 97, 98, 80%. HBST grown are mostly 2A and sometimes 1B, and CVD grown are majority are just 2A. The instruments who will screen these types, I put them in blue. The instruments who are looking based on fluorescence, phosphorescence, and mostly if they fluoresce, natural diamonds fluoresce stronger in the short UV, long UV light, sorry. As synthetic fluoresce stronger under short UV light, as you can see, HBST grown. And those very rare CVD that do not fluoresce or fluoresce equal. Sometimes short UV is stronger, so we can also apply these instruments. The last group is most complicated, based on impurities in a diamond. Basically looking for nitrogen as a pairs in natural diamonds, or single nitrogen in a HBST grown, or hydrogen or silicon in CVD grown diamonds. This is the first instrument, quite simple, and but it requires some time to master it. To put the diamond at 2 polarized filters at 90 degrees and look at the reaction. You can see under the microscope how it looks with a portable polariscope. And this is natural diamond in the middle, and then the bottom is a typical parallel structure of CVD grown diamond. It's quite different reaction of type 2, what is rare natural diamonds, maybe 2%, 3%, we call it a tatami pattern on the left, and typical strain in one type 1A diamond on the right. This is 3D effect. It's very important to rotate the stone while we are looking the diamond. And many diamonds have yellowish tint, we call them Cape diamonds, and sometimes this reaction is a little bit more difficult to notice, but you have to rotate the stone. This is the same stone in fourth position. You can see some kind of blue, I call it smudge pattern, brownish, grayish color coming while rotating the stone. As is very opposite in this reaction is basically no pattern, or because it's very short time the diamond was growing by HBST process, and basically very low strain or almost no strain, typical for HBST grown diamond. Very different from parallel. You can see on the bottom very typical reaction of CVD grown. Sometimes it's not so easy, as you can see on the top, could overlap with some strong reaction in type 2A natural diamond. So it is good technique, but not 100% technique. Needs to be backed up with another instrument. One that I like to use is, of course, UV lamp fluorescence reaction. In this case, we can see the bottom right, one bracelet with a lot of natural diamonds, and as you can see, they can fluoresce from non to weak, medium, or strong blue, but it's typical for natural diamonds. And synthetic usually have stronger short UV light and mostly greenish or yellowish green or green yellow. This is very complicated chart, but I will just go for the basic colors. What we see in natural diamond usually is blue, caused by entry center. You can see on the top left 415 line and other band. Green is associated with usually some kind of heating irradiation process. Most typical center is H3 or 503, and envy center is either 575 or 637, very typical for also multi-step treated diamonds, natural and laboratory grown. This is collection I kind of use in my workshops, and I was able to choose 55 diamonds and 7 imitations of different origin, natural, HBST grown, CVD grown, and natural color or treated. That's why some imitations. And this is a very useful test I did with 11 instruments, but I'll present now 7. Hopefully you will see some reactions and get some information that can be useful for you. In this kit that basically have a PL inspector, what is a mini UV lamp, and portable polariscope, we can see on the top a typical natural diamond, top left, and in the middle HBST grown, and on the right CVD grown. You can see how fluorescence is a little bit stronger in HBST grown and CVD grown, but opposite in long UV is stronger in natural diamond. On the bottom you can see reactions under cross polarized filters of type 2A natural. On the left, tatami, no reaction, HBST grown, and parallel or cross, very strong pattern in SCVD grown. I won't go into all these details, but just the idea is that in the book that you will see later, I'm presenting all the samples with different instruments. In this case, I'll just focus on fluorescence as important tool and cross-polarized filters. You can see, for example, in the case of blue diamond, fluorescence is much stronger and the phosphorus, no pattern, that must be HBST grown. On the bottom, this D15 is more complicated because it's very close fluorescence, very weak yellow is difficult to separate, but has very strong columnar pattern. And in this case, it's good to go to advanced instruments like photoluminescence spectra and confirm that it has 737 silicon line. This is kind of a test we would do, combination of 1, 2, or 3 tests to come with the result. This is a same idea, just a different size of instrument. On the left for loose diamonds, on the right for jewelry. You can see how all these diamonds are phosphorescing, mostly bluish, greenish, and this is HBST grown diamond. On the top left is one of the treated CVD diamond. And as you can see, there's some limitations of the instruments when it comes to jewelry or mounted stones, and we cannot use a classic spectrometer so well. We can use the kit, static kit with only if it's a solitary rings. Fluorescence is very good technique. Many instruments like beside the PL jewelry inspector, like diamond pen or J screen diameter using this technique of fluorescence. Transparency is limited, but some new instrument like ARRI has a like a fiber optic light and can see if open back even a small diamond. And of course, fluorescence is limited, but it's possible with the instrument that has fiber optic like EXA. As this typical example, long UV light on the left, you can see how it's much weaker in static diamond. On the right is stronger, and opposite for natural diamond. Very simple technique, and I use it all the time with the jewelry. Of course, ARRI is those for the jewelers or people who want to quickly see the if it's a type 2 or 1AB. If it's transparent to long short UV light, it will say CVD, HBST, or 2A diamond. If it's not, it will say diamond, like on the left. So it's a quick instrument, but it's not 100%. It has some limitations, and I will show later in the table. This is a diamond Jampen by geometric, sorry, that I found stronger than regular long UV short UV light. And you can see here, I'm showing one example of two stones that are relatively weak fluorescence under long UV light of, or we can call this is a filter 4, and very obviously stronger under filter 1, that is a short UV light equivalent. This is a good way to separate this CVD grown diamond as CVD. You can see here on their pamphlet, they're showing these different options, for example, for HBST grown and CVD grown diamond. And as you can see, in most cases, all cases, filter 1 is stronger than filter 4. Another instrument that is relatively new, it's called J Mini. Why Mini? Because it's relatively small. You can put maybe 5 to 10 or 15 pieces of sample maximum, loose or mounted. And what is good is that it's digitally it's circling the diamond that are potentially or definitely synthetic. You can see on top left, all these green and blue circles are HBST grown diamond, and this one on the bottom. This one is circled as red for further testing. And you can see on the right, I'm doing further testing another screen. And you can see these stones on the right do not fluoresce in this long UV fluorescent light. So these are CVD grown. And those who do fluoresce, this one on the left or these three, are natural diamonds. And of these, we put in these kind of charts. Of course, for jewelry, it is more complicated. And sometimes you need to combine 2-3 tests, not only one, to come up with a proper answer. I'll show an example later how somebody make the mistake on big diamonds. So jewelry is quite tricky because we cannot use all techniques, and it requires specific instruments and special care. That's why sometimes we need to go to a little bit advanced instrument, but now the price is going down. Like in Spectrum, it's now $3,500-$4,000 instrument that can take quick spectra of a diamond or other gemstones, and you can see photoluminescence and visible spectra of natural diamond that is typical, has cape lines. So this is quite good, but it needs some training, it needs some database, it needs some knowledge of spectroscopy. You can see here, for example, pink diamonds of different origin. Top left is natural diamond, top right is a multi-step treated pink, has envy center. Bottom left is a pink CVD treated stone that has a tiny 737, maybe not. Sometimes not easy to find these defects. And this is just a ruby, so I can do any kind of gemstone separating spinels from ruby and other gemstones. Personally, one that I like, I use a lot lately because I have a lot of rings and the jewelry coming to my laboratory. And when I see fluorescence is non or short UV is stronger, of course, I double check with the EXA because it's fast. And beside passing on the first level, what is good, ID100 doing the same, but ID100 does not show second level. What I like EXA because you can see the spectra of the stone. And you can decide if you're a gemologist or if you have some good books. This is either natural diamond on the bottom left, cape lines, typical for this natural diamond. This is typical, not always like this, so simple, but this is nickel lines in HBST grown diamond, or this is a silicon line 737, and it's a melee diamond in this ring. This is a line that you can see quite easily. Of course, I won't going to hold this table, but just to show you that it's possible to rank these instruments based on how much of these stones are detected. You can see, for example, kit is relatively good, 93 to 96, in my opinion, and the other instruments in this range from 90 to 100. Actually, there's not even one instrument, 101 instrument. This combination of instruments is good. Even X has got 97 to 99, but you have to go to advanced level, be trained to get this accuracy. So I you will see later, I arrange these instruments in 3 groups, and the more explained in the book and more details, but this is basically each of them has certain limitations on the color range, if they do imitations or not, number of samples, and of course prices limitations for some of them. Talking about price, I'm sure you will enjoy Thomas Hirschwanger talk, but this is an instrument that he made, and I think is very good, but it's quite pricey for the combination of mid UV laser and fluorescence to look at the small diamonds or any diamond. And this is another combination of instruments that combine visible spectroscopy and 2 lasers, 405, 532, that they use for example, research on pink diamonds. And of course, each stone has to be checked with infrared. This is very important. This is one from Margie Labs that is quite portable. Why we use this instrument? Because we can see these defects on the level of the atomic level. In this case, all these 5 diamonds from NDT that I checked 5 years ago has additional line of boron here that should not be there in type 2A diamond, and because all of them 2800, because all of them are HBST grown with additional boron present. And in this case, he also has single nitrogen in 270. So this is things you're looking in details once you do research or have a big stone that we don't have a fast answer using just standard portable instruments. This is kind of summary of what we can see in the past, like 15 years ago, 20, when I started to study these stones. Metallic inclusions are quite visible, but now most of the stones are VS and higher, so we cannot see or characteristic birefringence pattern. It's great to see, but sometimes it's not so obvious or overlap CVD in 2A. Fluorescence also is very important. When we see it, it's still valid, but sometimes it's not always there. So we need to go to advanced instruments, and here is the list of X, UV visible, infrared, photoluminescence, or this based on a pattern like diamond viewer or DFI. Altogether, a couple of weeks ago, I made this chart with John Jampen for the GS Symposium that we try to give us steps or advice to people what steps to use in checking laboratory-grown diamonds. It's still valid. Of course, we cannot explain everything, but this is 2 ways of doing standard instruments based on UV transparency and based on fluorescence. Of course, if inclusions are there, they're important, but if they're not there, we need to really see if it's not transparent UV light, most probably it's natural, or it is. If long UV is stronger than short UV, then it's natural. But in case it's non fluorescence, we need to check birefringence pattern and decide if it's non or columnar, then synthetic. If it's typical type 1A or type 2A tatami, then it's natural. Sometimes it's overlap this pattern or no fluorescence. And I have a few stones like that. We need to go to advanced spectroscopy, infrared, photoluminescence to look at different defects or look at the CVD pattern, CVD impurity silicon, or sometimes if it's completely everything not present, we need to look at the growth sector patterns in a diamond to make sure that it's growing in nature or it's layered or geometric, what is happening in the laboratory. And I really want to encourage you, if you want to get this chart with the pictures, you can just sign up on brankogems.com and get this chart for free as an email. So this is something I want to encourage you. First example, how is important identification. It could be $50,000 ID mistake if you are basing your conclusion only on one simple test. You have to combine 2 or 3 or have experience with that 1 or 2. 3 is always the best from each group. This is a stone, it was 2 weeks ago, came to the laboratory. Local jewelers and even local lab, believe it or not, call it laboratory grown because they have very unusual fluorescence. It's green and has very unusual clouds that they didn't see before, or they were confused with the clouds. You can see maybe here some clouds. But long UV is stronger than short UV. This is the first indication the stone is natural. Of course, they were confused also because they use ID100 and some other screening instrument that says referring. And people think if it's referring, it's synthetic. No, you're just referring to do more tests. And many jewelers don't think like that, unfortunately. So, of course, when I put on a second level X, I see that has additional band close to 800 that is associated with nickel and hydrogen, and use infrared to see that this is really a high hydrogen diamond type 1A, typical for these cloudy stones, and fluorescence is caused by this amount of hydrogen and nickel. So everything fits in natural diamond of unusual characteristics. But one test is not enough. This is example difference between $20,000 and $70,000-$80,000 stone, because it was a low color KL, but it was still S1 stone. And of course, we can use this for different type of colors. This is pink diamonds of different origin. This is natural. Second one is HBST grown treated. Third one is CVD grown, and the last one is multi-step treated. If you look in the fluorescence only, we can see that these three are not natural color. But then we have to go into spectroscopy to prove if it's CVD or HBST, or look at the pattern. So basically, it's always a combination of 2 or 3 tests, in my opinion, and that's how I would like to encourage you with this talk and my books that to combine more tests, not only one. And this is how I summarize these instruments in 5 groups based on performance and a little bit on their basically their technique. First one are based on visible pillar spectroscopy. They're up to 4%, 1 to 4% accuracy. X in spectrum ID100. Then J-mini maybe 3 to 6 because it's digitally helping you to circle the stones. Then KIT because combining 2 instruments maybe 3 is 4 to 7%. And then the instrument based on fluorescence still good, but not maybe 5 to 8%. It's referring to more tests like the diet through PL Joule Inspector, Jampen. And transparency to short UV light, it is a steady diamond screener to ARI and Vista. I didn't explain all of them here, but this is the instruments that are part of this study and part of the book. To conclude, I would like to say that every jeweler, every gemologist, every appraiser has different needs, and they need to really spend some time like at talks like this, or the best to spend half day with me or some other organization training or trade workshops to really see different instruments. And I combine really standard and advanced in infrared, of course. And there's Alberto Scarani and Miko Armstrong, my friends from Agile Labs, and me and Dusan Simic stated in our books last year and this year a new one. The best is to combine 2 or 3 instruments, not only one. Otherwise, it could be big mistakes. And the many papers that I did with different great scientists and researchers around the world, I will encourage you to read some of them. Or if you have a chance to get the book, just came out last week. And this week I was busy in Serbia mailing and sending this book around the world. And GEME, very helpful, very grateful that they ordered the books as well. You can order from GEME, you can get from me. But based on this is a book that is advanced level, talking about these portable instruments. This is my article, but also talking about spectroscopy from Dr. Alan Collins and Dr. Oksana Zaitsev, talking about production of laboratory-grown diamond. And I want to thank GMA for giving me this great article from a few years ago. Now it's updated by Dr. Tejin Lu from NGTC, and Diamond Treatment by Victor Vins. And of course, we have John Chapman as the editor, also talking about review of principles of advanced instruments, and Thomas Henschwager finishing it with a lot of spectroscopy, a nice overview of fluorescence imaging and testing by spectroscopy. And Dusan Simic and Miko Armstrong did a nice review. And this is the last year book and this year book, and both of them are around 200 pages, and I will encourage you to read them if you want to learn more about diamonds of different origin. And I hope I didn't go too fast or didn't go over my time. I'm open for questions, and I want to thank our sponsors and people who participate. This is, we all try to educate trade and you on this topic.
Thank you, Branko. That was brilliant. We all really enjoyed that, I'm sure. We have one question here for you.
Okay.
I'll read it out for you. Is there a specific instrument that would work well with mounted gemstones, say in rings or bracelets?
Yes, there are a couple of them. So one that will work from more simple one is ARI, that it's based on UV transparency, but because it's needle based, you can touch the melee diamond even mounted or bigger stones. The other ones are Jewelry Inspector, Geometrics Australia, that can check jewelry, or Jampen from Geometrics from Sweden that can check also even necklaces. You can screen a whole necklace very fast around the whole necklace. And also, I would say EXA is excellent because you can do one stone at a time. And the difference between a fluorescence instrument and EXA is EXA can do one stone at a time. You can see the pass or no pass, or see the spectra. This is instrument I would recommend for jewelry that I tested, and I'm using it.
Great, thank you. There's another one here. Has he tested the Sherlock Holmes? I haven't seen that on any of his lists.
Yes. Okay. I did not use it in my study for simple reason that I couldn't get it just for study. Usually, I don't buy instruments just to use them in study. I buy those that I really use in the laboratory and then use in study. But that one I've seen at the Tucson show and other shows. Seems to me it's also based on fluorescence and checking on fluorescence of diamonds, but I'm not sure how accurate it is. I think it's quite popular lately, but I know that it is not 100% for sure. It's not like a magic box as maybe some people trying to present. I think it's a good instrument, but the company is not showing everything about the instrument, and I don't know. I'm not. I cannot comment more because I just didn't use it for my study on my samples. I wish I maybe for next edition of the book I will use more instruments, but just it's not easy to get them, and each instrument is tested on 62 samples. It's also time consuming. Yeah.
Great, thank you. There's another one here. How does your study differ to NDC's Assure program? Which is more reliable?
You're talking about comparing to a short program?
That's all the information I have, Branko. NDC's Assure program. Maybe whoever asked the question.
Yes, Assure program.
Okay.
Okay. Yes. I can say like this. I read the article about Assure program, of course, and I see what they did. I think they focus more on colorless diamonds and on certain. My problem with that program is I don't see a characteristic of these diamonds. So I don't know. I just see results, but I don't see characteristic for diamonds. I cannot read, for example, oh, this is this type, this is this color. They're just saying it's a range, and they're saying it's colorless and things like that. But I think I'm quite transparent in my study because I'm listing. It took me a lot of time in 6-7 pages. All these, you saw some of the samples, all these stones, characteristics I did in the laboratory, and then testing with these 3 groups. So my study is different from point of I'm more disclosing the starting material, what it is, and giving the results. So by stone. So it's a little bit different from that point. They're giving the results, but we don't know starting material. I mean, they're just describing it very generally, and this is my issue with that program because it's not completely transparent in my opinion. But this is just my opinion. Yeah. So.
Okay, thanks, Branko. There's no other questions, but just lots of other comments saying thank you so much. Wonderful and informative presentation, helpful overview of new instruments, and of course from Gemme as well. Thank you very much for your talk today.
Yeah, thank you, Christopher. Thank you, Nisa, and the Gemme for hosting me, and hopefully I will do it again and see you in Tucson show.
It's been our pleasure. We look forward to seeing you soon.
Yes, thank you.